Hello, in this video, I would like to try some examples of cutting polygons in order to explore the area formulas of those basic shapes. So in the polypack, okay, start with some geometry tools here. I can create any simple shapes using this custom shapes tool. Okay, so I just drag one here, and I need a grid to do a better setup at the beginning. Okay, just to make it easier to create some simple shapes. Maybe let's try. Okay, let's try this one. Okay, so this is a parallelogram. So we can close the grids if we don't need it now. So suppose we know that this is a parallelogram, right? We can talk about its area by doing some cutting, right? Some basic cutting can be here. And let's see. I think it's right. Okay. Right. So we can now make a rectangle, or we can check it whether this is really rectangle, where we can find the area. In polypaths, we can also use the label. Okay. We can use the $sign A to represent area. So you can see this is the label for this rectangle. It shows the area. And in fact, this is the same as the original parallelogram. Okay, so this is a very simple demonstration, right? And let's try to, let's say, cut it in another way. So if you select the original two shapes, you can also join it, right, again. So you can get the original, okay, parallelogram. And you can also rotate it. And maybe you would like to cut it in another way if you like. Somewhere like this. Then rearrange it, right? If you can compare the two rectangles obtained in this way. Okay, let's start with another parallelogram. So, by the way, this is a custom tool. So you can use it to make any polygon you like. And if you click on any one of the vertex, right, then you will remove that vertex. Okay. And if you want to add one vertex, you can click anywhere on the side. Right here, for example, okay, and I also click it here, anywhere to create another vertex so that you can easily reshape it. Right. Once again, if you don't need it, then you can just click any one of this vertex to remove it. Now I have quadrilaterals again. Okay, so maybe I want to study. Okay, this one is more challenging, parallelogram. If you want to cut it into pieces, okay. Is it easy to reform a rectangle again? Let's try this way. So I also do the cutting. Right. So basically I drag vertically up, right? And then I have a triangular piece, but I can't form a rectangle immediately. So we may try another cutting, this time horizontally. So at least I have partly a rectangle, right? And then perhaps another cut here, I guess. Okay. So very nice. Then we can get a rectangle after some trial. All right, so let's see. This is the rectangle we have. Okay, let's get back to the original parallelogram, right? So it shows that the original parallelogram has the same area of this rectangle, which should be actually equal to also the base. Again, this is just the base. This width is just the base of the parallelogram. And the height is not changed, right, throughout our transformation, right? So it shows a little bit more complicated cutting, but the principle behind is more or less the same, right? Right. Now, before I go on to other polygon, I would also like to share briefly another possible use of this kind of shapes to study parallelograms area. Now, this time perhaps I make something like this. okay, a right angle trapezium. And so on the right, you can see we have two right angle, but on the left, I have just a ordinary inclined side, and it's still a trapezium because the base, the two bases are parallel. Okay, now, but I want to use it to actually generate a parallelogram. First of all, I have to change the transparency. Okay, make it easier for you to go see what's behind. Okay, something like this. And I want to copy it. All right, so I have another copy, and I can also change the color. Right. So maybe this one is good. Let's see. All right, so you can see it is now overlapping exactly the same thing because I just copy it. So if I slowly slide it horizontally like this, okay, on the right, so you will see a parallelogram. The green one here is the parallelogram. It's a parallelogram. How can you tell its area? Now on the right, you see, perhaps you can see a pink rectangle. Okay. In fact, you can compare the green shape, that means the green parallelogram, and the pink rectangle. Okay. Try to talk about it. See how you can understand why the pink rectangle should be the same as the green parallelogram in area. In this way, in fact, it is also a kind of transformation, okay, to change the parallelogram into another shape of the same area. Okay. So go ahead and try to explore this. Actually, no matter how far you drag to the right, okay, then the parallelogram on the left is the same as the rectangle on the right. Okay, so that can be another way to discuss the area of a parallelogram. All right, so after this one, we will go to the case of triangle quickly. So because for triangle, we can also make use of the previous result. That means turn it into a parallelogram and then talk about its area. All right. So one way of doing it is like this. And you can start with any triangle you like and then make a copy. Okay. And then flip it. Oh, sorry. Rotate it. Okay. And you should see a parallelogram. So this is one way to find out the area of the triangle. That means to consider this being half of a parallelogram of the same base and same height, right? But you can also cut it. Actually, if you do some kind of, let's see, we can add some line here and go back to the black color. And now we can perhaps produce some lines here. And let's say, oh, sorry, I should not use a rectangular tool. Just undo it. All right. So I just add segment to enclose the triangle to remind us this is the original shape, okay, before we do any transformation on it. At the same time, you can also have some simple construction. For example, you can have perpendicular line, okay? So you can draw a perpendicular line of this line through this point, okay? So maybe I try it again, select the base, and then draw a perpendicular line of it through a particular point here, okay? And then here we need the intersection. So we go to the line tool, but this time we use the line tool just to draw a point. Okay, just click here, then it will give you an intersection point, right? And so perhaps you don't need this one. If you don't need it, then you can hide it, okay? Make it invisible, okay? And what we are going to do is to actually cut it into two parts, right? Through the altitude, through the height here. And then perhaps you can also copy this part, right? Rotate it. Similarly, you can also copy this part and also rotate it. Okay. In this way, you directly get a rectangle equal to twice the area of the triangle. Okay. And this will also help you to find out the area of the triangle using the formula that we are familiar with. Okay. Another way of doing it is like this. Let's add a segment here, right, to show that we have the mid segment, the altitude of the altitude of the triangle, okay, and we can add the midpoint through this, or maybe directly use the perpendicular bisector if you like. So we can directly bisect it in the middle, and also add the point on the side, okay, to mark this mid segment. Okay, and once again, you can hide it, make it invisible, and use it to cut the triangle. Okay, maybe both of the triangle. Let me see. Okay, I think we'll cut it separately, right? And do the same. Okay. Now we can see the upper part is being divided in two. And when you rotate it, and then you can put it under next to the part below. Now in this way, you can still have a rectangle, and this is exactly the size of the original triangle. All right. And this rectangle has a base, has one side equal to the base of the triangle, and the other side is half of the height of the triangle. Right. So that can be another way to talk about the area of a triangle. Okay, and let's now look at perhaps a trapezium. Okay, so we open the grid again and get a custom shape. Okay, and now we can use it to make a trapezium. So maybe we can make a trapezium like this. Right, it can be anything. Show hide the grid. So one way to find the area of the trapezium is to duplicate it, just like what we did with the triangle earlier, and we make a copy. And or you can also change its color, right? And then try to rotate it. And we have now a parallelogram, right? And you can talk about the side here, which is equal to sum of the bases, what we call the two bases, okay, top and bottom, adding together. And this is the original height, okay? So you can find the area of the parallelogram and then take half of it. That will be the area of the trapezium. So this is one way of handling it. Just like the previous case of a triangle, you can also actually enclose it by some segment. Okay, and then also we can have a perpendicular line to the base. Okay, and here we add one more point to mark the foot of the perpendicular. And well, you can hide this one, replace it by a segment. And based on this segment, you can also add the perpendicular bisector, right? So that you will see the midpoint here, right? And you may hide this afterwards, right? Okay, for the original trapezium, now you can cut it through the middle. Okay, and here we have an upper part which can be rotated and then join it with the lower part. Now we have a parallelogram. You can check the length. This is the base, which is the sum of the top and bottom. But more interesting is that, how about this length? Okay, this side at the top. Is it the same as the one here we see below? Right? Maybe if you want to investigate it or prove it in detail, right? That can be a good exercise for the student as well. And I mean, for some students in secondary school, right? You can talk about this length above, see whether you can confirm that it is the same as the length below here, all right? And it will lead us to know how the parallelogram, the trapezium, can be transformed into a parallelogram, and thus using it to find the area. So this is one possible way. Okay, and so let's go back to join it. And perhaps we can remove this segment, right? Now I would like to join these two again. So go back to the original trapezium let's try one more way to discuss the area. And this time I cut it through, right, the diagonal like this one, and then rejoin it. Okay, basically it is now turned into two triangles, right? And you can talk about the area in terms of the areas of these two triangles will share the same baseline and also have the same height, okay? And then you can use it to find out the area of the original trapezium. But more interesting is that you can actually replace this one, maybe I turn it into orange. Okay, and so just add this triangle to the original. Oh, sorry. So let's fill this part with our new triangle. Okay, so we'll get back the original trapezium, which is the same as this green one. But this green one is now being cut, therefore you cannot alter its shape. But for this new one, I can still alter shapes. Now, but before I do it, actually, I still also like to rotate it so that I can put it back to the bottom. But this time I can drag this vertex. Oh, sorry. It's not this vertex. It should be the vertex of the triangle. Okay. While doing so, I should not change the area of the orange triangle, right? Because the baseline is not changed, the height is the same, okay? But in this way, we have a nice new triangle exactly equal the area of the original trapezium. And when you try to talk about this length, okay, it is the base is the sum of the top and bottom, and the height is that of the height of the trapezium. So this can also be an interesting way to find out how we can calculate the area of the trapezium, right? By looking at different ways of transforming, cutting and rejoining the polygons, right? Okay, maybe I stop here for this video. Thanks for watching.